This assessment asks us to calculate the HOMO-LUMO gap for a hypothetical green dye that we are developing. The equation that we'll need is the lambda is the wavelength of light that we're absorbing, and that will be equal to Avogadro's number times Planck's constant times the speed of light divided by delta E, where delta E is that energy difference between the HOMO-LUMO and the HOMO-LUMO gap. There's a couple of things we need to know to use this equation. Green dye would absorb approximately 700 nanometer light. Na is Avogadro's number, H is Planck's constant, and C is the speed of light. We'll need to know those values as well. We can use those values in this equation to calculate our delta E. And so the wavelength of light is approximately 700 nanometers. And that will be equal to Avogadro's number, 6.02 times 10 to the 23rd per mole, times Planck's constant. Now, Planck's constant is given to us in joules seconds, but delta E is typically in kilojoules, so we need to convert delta H to kilojoule seconds so we can use it in this equation. That's scaling by a factor of 10 to the third. So we'll use 6.63 times 10 to the negative 37th kilojoule seconds for Planck's constant. And the speed of light is given to us in meters per second, but our lambda is in nanometers. So we need to convert meters per second to nanometers per second. That's scaling by a factor of 10 to the 9th. So we'll use 3.00 times 10 to the 17th nanometers per second for the speed of light. And all of that will be divided by our delta E value, and that's what we are trying to calculate in this equation. When we do this math, we find that delta E is equal to approximately 171 kilojoules per mole. So this is the delta E, this is the HOMO-LUMO gap for this hypothetical green dye. The HOMO-LUMO gap for this hypothetical green dye is approximately 171 kilojoules per mole.